Yay! Okay, hello everybody. Thank you for coming. I'm really excited to be here. My name is Baruch Sadogursky. I'm developer advocate with JFrog at JBaruch on Twitter and every other possible social network. So feel free to connect. This picture describes perfectly what you need to know about me. Something very important. JFrog.com/show notes have a page dedicated to tonight's meetup. I will upload the video that I record now over the screen and the sound, so you will have like this talk recorded. The slides are already there. All the links that I'm going to talk about, including some links that I won't even mention, but they are related. So give it a look. Feedback forum and some nice raffle of some nice prize just to thank you for being here. So feel free to get in and enroll to that as well. JFrog, who heard about JFrog? Artifactory. Okay, that's not bad for an East Coast, considering that Sonatype are sponsors of this meetup, especially, right? So yeah. We're going to talk about mostly about managing Docker images in general with examples that I will bring from Artifactory, which is a universal artifact repository that also supports Docker. But we have a bunch of other products in JFrog. JFrog Bintray is a universal distribution hub. So if you have software that need to be downloaded to clients, whatever those clients are, people, IoT devices, smart cars, or whatever, that can be a backend of your download service. Mission control, big guys among us that have multiple HA clusters of Artifactory use mission control to manage and monitor them. And JFrog X-Ray, which is a universal component analysis tool that scans the artifacts recursively and finds stuff that you care about, such as vulnerabilities, licenses, versions, obsolescence, and whatever it actually makes sense to you. And yeah, we are hiring as well. So join.jfrog.com if you are interested in working for JFrog. Okay, now let's have some fun. Just show of hands, your relationship with Docker. You vote and then you just keep your hand up until it's no more relevant to you. So let's do it. By the way, right here for you, so you won't forget. Okay, who heard about Docker? Okay, keep your hands up. That's the fun part. Who can do the tutorial? Still everybody good. Played with it actually for work. Tried some stuff for work. Okay, still like 90%. Production. You can take your heads down now. Your hands down now. Okay, 1, 2, 3, 4, 5. Okay, so we went to what, like 10%. And that, of course, was a manipulation on my side. That, as you can guess, I know exactly what is happening because I do that all the time, and the results are always the same. Maybe we moved from like 5% to 10%, but it's still the adoption of Docker into real production systems is ridiculously low. And the question is why? And there are probably a lot of answers, and each and every of us have their own. I would say that a lot of people will say that Docker looks like a very cool and promising technology, but I'm not sure I can trust what's going on. And because, you know, those Docker images, containers, it's another opaque level of abstraction that's something going on inside. And until I can be 100% sure that what runs inside Docker is indeed what I wanted it to do, it's kind of problematic. There are, of course, other reasons like security concerns, like stability of Docker, backwards compatibility. There are a lot of reasons why people hesitate, but we get that a lot. So today we're going to talk about how we are going to fix that. How can you make sure that whatever you want it to be in your Docker image is indeed in your Docker image. Why am I speaking about that? By the way, that's a hug, if you wonder. It's a frog hugging word, because we love Docker. We, as I mentioned, JFrog Artifactory is a Docker registry, and we believe that it's a good one because of that. So that's Solomon Hykes, of course, the creator of Docker, speaking DockerCon 2015, almost 2 years now, in San Francisco, and asking this question: who uses Docker and nothing else? And what he meant by that is that shop that only does Docker, doesn't do anything else. Anyone? You only do Docker? So okay, so
do you mean like for our production environment?
Well, no, I mean, do you have any other technologies besides Docker?
Oh yeah.
Oh yeah, thank you. Right, and that's because the analogy of container plays very nice here. No company in the world ships empty containers, right? The whole idea is to pack something inside. And that's true about Docker as well. And that brings us back to the benefits of a universal artifact repository that can serve as Docker registry, obviously, but not only. Whatever you put inside Docker, being it Java, being it .NET, PHP, Ruby, Python, native code, C++, you have other technologies that have the same needs, right? And having all of them on the same, working with the same tools is beneficial, not only because you just have less tools to manage, but most importantly because you need to correlate those things one between another, and we are going to talk about that, right? So being relatively new, it's not that new by now, 3 years, 3.5, right? Not very new, but still not as the other technologies that we use. We as software engineers just look for familiar patterns to do that as well. And then we ask the question, should we adapt it, or can we take it for as it is? And that's what we're going to talk about today, how we build continuous integration and deployment pipelines with Docker. Can we use whatever we used to do for everything else, or should we make some adaptations, right? And the thing is, continuous integration, continuous delivery pipelines, we actually do them for years, right? Continuous integration, everybody, for many years, nothing new, at least I hope. This is how it looks like, and that's the promotion pyramid. It's kind of hard to, for me at least, was put it on a slide, but what I try to convey here is that your promotion goes from the bottom up. You start with a lot of very short tests, and a lot of builds fail them, and then you promote through those additional quality tests. The test takes longer and longer. After unit test, you get to integration tests, which are longer, and then system tests, which are longer, stress tests, UI tests, maybe manual QA, but you have less builds to test because a lot of them fail on previous stages. And the same image, just in another direction. This is how the pipeline looks like. So what we are trying to do here, we have those binaries, and then we promote them through what are called quality gates. Quality gates are tests, right? So here we have dev environment, and then system test environment, and then staging environment, and then production, and we promote between those environments by making those tests and pass those quality gates. Does it make sense? I hope this is not news to any of you, right? You do it, as I mentioned, you do it for years, and the question is, can it work for Docker? And I would claim that not a lot of people do that in Docker because of the one simple reason, and it's the Docker build command. Now, Docker build command is extremely powerful. You can write whatever you like in the Dockerfile and it will work very nicely, right? Any command you can put there. And then you can just run this Docker build as many times as you like. And frankly speaking, this is what most people do. They just run Docker build each and every time in each and every environment. So we end up with something like that. We have the same pipeline, but instead promoting the artifact, all we need to promote is just one text file, the Docker build. And promoting text file is by far easier than promoting the artifact, because all you need to do is move it between branches in Git, or even tagging that differently in Git. This is very easy thing to do, of course, for every environment, but the problem is what's easy, cheap, and powerful, not always the good way to go. And that's for the following reason. So when I created this slide, I wanted to go and write some ridiculous Docker build that, you know, every line of it will be a dependency resolution to the latest version. And then I just went online and I discovered that all the internet full of this. And people actually do that and people actually use it, right? So I don't need to invent anything. This is how the industry works. And this is terrifying because, as I mentioned, almost every line here, except maybe of creating directory and then running a command line, is a dependency resolution to the latest version of artifacts. Okay, and as you can imagine, if I run that multiple times, the chances that I will end up with the same image are not very high. And here, all of you, especially whoever voted for using Docker in production, should say, well, that's just a bad example. We can definitely fix it, right? So let's fix it. Let's play this game. Let's start with fixing this guy. So we can provide the version, right? Does it fix it? Talk to me. No, why? Why don't fix it? Release version should be good.
Python version, OJS.
No. We will get to that. Let's start with the from line. Let's fix the from line first.
Isn't the tag mutable? Can't like they read?
Oh, thank you very much. Look at that. In Docker, the tag is mutable. The fact that I think that is a release version, which I used to from whatever technology I use, right? It's if I have a release version, it should be the same in Java, it should be the same in Ruby, it should be the same in every other technology except of Docker. In Docker, the tag is mutable. And here is a dilemma for canonical guys, the guys that maintain Ubuntu image. Well, 14.04 was 3.5 years ago. And it was a good release. And tons of people still use it, but something happened between April 14 and now. What happened with Ubuntu? Big one and scary. Heartbleed, systemd, and bunch of other security catastrophes that we had over those 3 years. Now, as I mentioned, this tag is still very much in use. It is very much in use because, you know, people that maintain operating system versions don't really like to upgrade. Because when you found something good and it works good, you just stick to it like forever. And here's the dilemma for canonical guys. From one side, 14.04 is a release version and should be stable and immutable, as we know from any other technology. On the other side, people still use it, so we can upgrade the security fixes to the latest patches and then make it much more secure. And of course, that's the right thing to do on their side, but what it means for us is that if we run this build multiple times, we very much may end up with different image every time, just because 14.04 changed its meaning between the builds that we run. Is there any way to fix that?
You have the build number?
I don't think they publish build numbers.
Save your own.
Save your own. That's a very good one, and that's the right answer. We'll get to it, but now let's play with the wrong ones for a while.
Manage your own Ubuntu repos. Sync.
Oh, latest is what we started with. That's latest. And that means you have no idea what you're going to have. And especially in April and November. November, right? The 11 or 10? 10, October. That's especially 2 months when you have no idea what's going on. So yeah, how we get from that to something more stable? Fingerprints. SHA-2. This is very stable. Every time I'm going to run this build, I'm guaranteed to get the same from image, the same base image. By the way, do you know which one? I think I just, bumped my head on the keyboard and got that. I'm not even sure it's a real checksum. I mean, this is very stable but completely useless. I don't know which version I'm using.
You need a comment.
How about those guys? Can I fix them? All those? The Python and the Node.js and all those? Of course we can, right? How do we fix them? Release version numbers. I can put here a number, apt-get, and then a version. The same with Node.js, and then a version. And it will be stable, it will be good. How do I know that apt-get actually receives the version here? Just because I know apt-get, right? How many of you are Java developers? Okay, a couple of hands. How many of you know Maven? Okay. And how many of you think that I can guarantee that this line will always resolve to the same set of files? I know that it's possible. You don't want to know how. And that's because I know Maven and you know Maven. But how about that? What this guy is doing? I have no idea. So my point is, there is almost no way, or at least there is no way worth trying nailing down the dependencies that you use in your Dockerfile. And what it actually means is that you get that. Every time you run a Docker build, you have this danger of producing a different image every time. Because one time, the base image changed. The other time, Maven decided that it needs a new version. Or it just have a new version of Maven, which now resolves dependency differently. Or something else, right? Or something changed in your scripts. You can never be sure that what you have in production is what the developer wanted to be in production if you promote a Dockerfile and not a Docker image. And that brings us to another pattern, in which I guess most of you familiar with, Immutable server pattern. Heard about it? Okay, a couple of hands. That's good. That means that this session is even more useful, because I'm going to teach you another pattern, and that's the Immutable server pattern. Now, back in the day, many years ago, when servers were actually hardware, and we used those racks to have servers there, and then when we wanted to change the configuration of this server, we used to SSH to this server and change the configuration. So we had a service, and then we had a change, and what we actually did is applying configuration, right? And if we had a lot of those servers, the chances that we were able to apply the same changes to all of them consistently were not very high. So now, when servers are cattle and not pets, when we don't care about them and we can discard them easily, what we should do is something that Martin Fowler refers as immutable server pattern. And that basically means that if we need a change, we throw the old server away and we code a new server with different configuration and make it available instead. And we need another change, we will do the same. We will throw it away and have a new one. I guess you know that that's the way you should act now, and now you also know it has a fancy name. It's called the immutable server pattern. Now you know. You probably already do that. You just didn't know how it's called. Now you know. So yeah, and this immutability, what we propose, is taking it one step further. Instead of only doing that for production and runtime environment, we actually propose you to do it for promoting your images as well. So instead of building in each and every step, you just need to promote immutable and stable binaries and having something like that. You create your image once, and then you promote it, the same image, the binary, well, a bunch of binaries of your Docker image through those quality gates, from development to staging to production, and you might have even more, of course, of the steps in your promotion pipeline, right? And those quality gates here are the ones that give you the test that you need. And now it's about time that you should ask what's up with those gates and why this guy is so upset with them, so obsessed with them, it almost looks like that. Well, the difference is I have a good reason. And the reason is that the QA shouldn't test images which are not ready to QA. The not tested images should not be staged. And the most important, not staged, not tested, or dev images should never ever end up in production. And the only reason, the only way you can guarantee that is having strong quality gates. The problem is that having strong quality gates is difficult to achieve with Docker. And there are many ways in which you can implement the quality gates in Docker. For example, you can embed information about the location in the pipeline in the Docker tag, in the name of the Dockerfile. So you can have my app dev, and then retag it to my app staging, and then retag it to my app production. This is something that you definitely can do, but as long as they are all in the same Docker registry, your production environment have access to development images, just because they are in the same registry. The strongest quality gates that you can achieve are different Docker registries for different areas in your pipeline. And this is what you do already for any other technology other than Docker. So whatever repository you use, whether you use JFrog Artifactory, or you use Nexus, or maybe you even use Archiva, or private installation of NPM registry, God forbid, whatever you use, you already do that, because in your repository manager, you already have different repositories for different stages of your pipeline, right? So let's take, again, Java.NET or whatever, for example. You will have the dev repository or registry or feed, depending on technology that you use, and then you will have QA, you will have staging, you will have production, and your pipeline will promote artifacts from one repository registry feed to another. With Docker, it's not as easy as it should be, and as it is in other technology, and that's because we have pretty trumped up, this guy again, limitations. Something that is not really have to be, but it is. And with Docker, the problem is the Docker tag syntax, the Docker tag standard. So this is a Docker tag command that you're all familiar with, that receives an image name in a format of registry host / username / name, and then semicolon the version, the tag. You're all familiar with that. Except of the name, everything else is optional. If you don't provide the registry host, the default will be a Docker Hub. This is not something that you want for your internal images, so you will provide a registry host. But the problem is the separator that Docker decided to choose for separating different parts of this name. Because from what I remember, / is kind of already taken. It's the separator in the URLs, and registry host is actually a URL. How can I have more than one registry per host if after the / of the host name, I cannot provide the name of the registry? How can I do that? I have a host, and then optionally a port, and that's fine. And then some context URL, which is optional, so I can skip it. So far, so good. But now the problems start. Docker dev, Docker QA, Docker staging, and Docker prod, I want them to be the names of my registries inside Artifactory for that example, but it doesn't matter. And only then I want to provide the name of the image. But the default standard of Docker tag won't allow me to do that because after the host, I have to provide the image name directly. I don't have this flexibility in the syntax of the Docker tag command.
Can you do username? Like kind of different users?
Well, yes. So I can abuse the username and pretend that this is the registry name, and some people do that. But first of all, it is a hack, and second, I do want to use them for usernames as well.
A quick question, because I really can run. When you do that stuff,
Right.
does it turn your Docker container to a de facto take as much memory as a virtual machine? Because one of the reasons when we started using containers, we're told it's going to make life very portable. So when you create what you're trying to create, because where you're going is you're going to show us how to create that, put them in separate registries.
Right.
Do you take as much memory as if you
Yes.
use a VM?
Yes.
So you become a VM, in other words.
We have a checksum-based storage, so regardless of how many layers, copies of the same layer you have in Artifactory, they are all
So
the same file.
it takes away some of the reasons to use a container. If you have using as much memory as a VM, then
Memory, that's what I feel now. Yeah, we'll get to that in a second. Well, so from our perspective, we manage images, right? Images are static files. They are not running. We don't deal with runtime. And what I want to guarantee that if you have this setup of registries as your steps in your continuous integration pipeline, and quality gates are actually about moving the image from one registry to another, you'll probably end up with multiple copies of the same image. And what we can guarantee that you actually will have only one copy of the file on the disk, so it won't take more space. That's my point. I'm not sure if it's related to what you asked.
well, oops.
I'm pretty sure it's not, but okay. Right. Okay, so how do we implement what we are talking about? How can we have multiple registries in the same host? And that's, of course, the first answer is, well, we don't even know if it's possible, but actually it is. And we can use virtual hosts or virtual ports to emulate more hosts under the same physical host. So what we can do is, when we type this Docker tag, host, port, and then the tag name, we will actually, this is what goes over a wire to the registry. That's how the protocol works. This is what goes to the registry server. And from there, we can translate it to this URL, which is exactly the URL that we need, because it does have here our steps in the pipeline, our different registers. And here's an example. This is Nginx, but it works the same with Apache or with HAProxy or with any other type of HTTP server that knows how to do URL rewriting. And what we are doing here is we are listening on a non-existing port. No service is actually bounded for 5001. And when the request is coming to 5001, we will take all the needed parts, and then we will go, instead of what it actually asks, to the same host and then /artifactory API Docker, the name of my registry inside Artifactory, and then the parameters that we get from the code itself. And we will have the same for 5002 that will go to Docker staging, and then we'll have the same for 5003 that will go to Docker prod. And this is how we have one physical host. This is one Artifactory instance. It's installed on one machine. It has the same file system that will deduplicate multiple layers and everything. But Docker thinks that we do have multiple physical registries on different hosts. Now, the question is, how do we promote? And again, if we go with Docker and we say, you know what, okay, you want multiple registries, now we have multiple registries. How do we promote from one to another? Well, we probably need to pull, retag, and then push back, and we are talking about hundreds of megabytes of a normal Docker image, which of course makes it very, very tedious. So our goal is to minimize the number of registries our Docker client works with, but on the back end still keep those quality gates in the shape of multiple registries. And we can do it with another abstraction that Artifactory has, but also other repositories have it as well, and that's what we call a virtual repository. Virtual repository can have, for resolution, multiple other repositories in the back. So when we have a developer that pushes an image to a Docker virtual, and these have one port, let's say 5000, in this mapping, it will actually end up in Docker dev repository. And then we can use REST API. We don't need to pull the image, retag it, and push it again. We can just use a REST API, promotion REST API, to move those images or to copy, up to you. We'll still have one instance of each layer from one registry to another. Now, all those are fully functional Docker registries, each and every one of them. They have their own virtual host or virtual port. And that means that runtime test environments that you have here, and you have test environment for dev, test environment for staging, test environment for QA, all of them will only work with those. And they will never know about others. And that actually means that here you have those quality gates that we are talking about. So if you have a QA environment now that only should see staged artifacts, the only registry it will know about is this one. So it will never test images that are still not mature enough to get there, because it won't know about that, it won't know about that. And when it's ready to production, again, we can use this virtual repository to also pull from it. So from the outside world, from the human interaction perspective, we only have one Docker registry that you pull you push dev images to it, and you only can pull production images out of it. Does it make sense? So the whole idea is we trick Docker to think we have one registry, but behind the scenes we have all those registries separated by the strongest quality gates you can do, and that means a whole new registry, and it actually the safest way to guarantee that what you have in production is actually what you want there to be. So the last part of the talk is kind of showing you an example of a Docker image and anatomy of Docker image that guarantees this promise of having in production whatever you actually intended there to be. And what I'm going to show you is a very simple Docker image that consists of multiple layers, of course, but three main ones. So we have a base image, which is some kind of operating system. We'll use CentOS for a change. and then we put some Java on it, but again, that could be whatever you like, right? It can be Node.js, it could be Python, whatever works for you. And then we have our applicative file. Again, this is a Java Word file, and it can be anything else that you like. So this is the image that I want to get in the end. And the question is, how do I build this pipeline so this will be guaranteed? And we will have two builds. One builds the framework, and the framework is everything except my application files. In our case, it will be the operating system and the Java on top of it and the application server on top of it. So we will take a verified base image, and by verified I mean something that we played with it and tried and figured out that it's good for our needs. We add system dependencies, which are, as I mentioned, JDK and Wildflying in our example, and we of course bring them from our own in-house repository, because this is how you guarantee it won't be changed to something else between different builds, right? You have your own cache, you have your own in-house repository from which you bring dependencies. And that's going back, you remember in the beginning I mentioned the importance of having a universal repository. This is where it comes to play, because those system dependencies, in case of CentOS image that I mentioned, are RPM images, right? And Artifactory, as you saw, is a Docker registry, but it's also a YAM repository. It serves RPM images. And this gives you the ability to put those dependencies on Artifactory as well, and then correlate one to another. You can express that in a certain Docker image, you have a certain version of Java. And you can express it in a queryable metadata, so you can always ask, okay, what is the version of Java that I put in this image? And you will have your answer, because both of them come from the same repository. The most important part of the framework build is that you own it. And then back to the correct answer that this gentleman gave us in the beginning of how you guarantee that you always resolve the same base image. Well, you own it. It's your base image. Until you manually act to update it, it won't be ever changed. And this is the most important part. And if, let's say, your application can run on a bare CentOS image, and you say, you know what, I don't need a base image. I can take any CentOS that I like, add my application file and run it, because I have a native code that just runs from bin bash. You still need the base image, because you need to control when they are updated. And the minimal framework build Dockerfile is absolutely ridiculous. You take one from the official registry and you own it. This Docker build will end up in a couple of milliseconds. You will get an image which is almost the same as the one that you have here, but you will keep it in your registry and you will use it as a base. And once you do that, you are shielded from whatever changes Red Hat decides to push into CentOS 7. You will always get yours. Now, it doesn't mean that you will never upgrade it or update the version. Of course you will, but it will be your decision. When you hear about the new version of CentOS that is out there, you will change it when you are ready. You will verify it, and then when you decide that you're good to go with CentOS 7.1, you will create your own new base and start using that instead. Yes?
One question. So, back to the promotion of the
Right.
Docker image from environment to environment. How do you maintain immutability of the server if you have to change some parameters on the image when it's in dev, for example, a debug flag or another endpoint, and
Right.
then in production,
Yeah.
obviously,
Yeah.
when it's in. So your server image is going to change, so you lose that.
Right. So the question is, there are back to our promotion pipelines, and the what I preach is promoting the same immutable image, but the image should change, right? Some aspects of the image in development are different than in this on production, And the answer is yes and no. Yes, they are different, but it's not the image itself. It's the configuration of the image. And this configuration can come in different ways. So we have a great Docker talk, which is called Docker 3 Ways. And with 3 speakers, and what we're going through a bunch of Docker features and explain how each and every one of them can be done in 3 different ways. And for configuration management, I think I can name 5 and not 3 of how you attach different configurations to the immutable Docker image in different environments. The simplest will be environment variables propagation. More sophisticated will be mounting different storage images with different configuration when you read from disk. And it can also be calling a configuration server like Spring Cloud or your own database and read the configuration from there. There are tons of different ways to do it. The image is still the same.
Another question with the pipeline.
Yeah.
How do you handle rollbacks? Like suddenly you propagate, you're in production, you see a problem, go through the same cycle again?
Oh, thank you very much for this question, because that's another reason. And the question is, how do I roll back? I'm in the middle of a promotion and I decided something that went wrong. And the answer is, well, for that you have Artifactory or any other Docker registry management. You just drop this image and use the previous one. You have all of them. They didn't went anywhere. They're all there. You definitely will have some cleanup policy, right? Because if you generate hundreds of Docker images every day, you will run out of storage, although it's cheap and accessible and everything. And this is something, again, your Docker registry software should allow you and should not leak this storage. But so again, getting back to the shameless plug of Artifactory, we have at least 3 different ways, again, to implement cleanup policies that you make sure that you still keep enough of the Docker images so you will be able to roll back and then a rollback from a rollback and then a rollback from a rollback from a rollback, but you still keep your space requirements reasonable. Yes?
Kind of going back to the pinned version talk. I guess my question is there, when you get to these long-term supported versions,
Right.
If someone is hosting, I want the security patches.
Of course.
And if you have those correct gates set up,
Right.
if you have a server that builds your image, tests everything against
Right.
it, and then pushes that image up, what's the harm in then letting those go? Because if they introduce a security patch that might break something,
Yep.
your test might fail.
Yeah,
or your test might fail.
Right, so that's another very reasonable way to do it, and it's definitely a valid point. So the point is, okay, Baruch, you told us never rely on those images on the internet because they change under your fingerprints, and 2 different builds will provide 2 different results, and that we agree. And then the question is, wait a second, but if I build only once, and then I promote my immutable image, what's wrong in having different images in this first stage? I will promote it through my quality gates, and if something goes wrong, it will fail on one of the quality gates, so I'm all safe. That's a super valid point, and that's one of the ways to do it. But what you can do instead is have your base image and have a different build that changes this base image every time. And if everything is good, you take this build image to your production build that will use that.
Because if not, you're stuck with this new broken one.
Right, exactly. Okay, so we kind of separated it to 2, and that makes sense. So if you have any questions on the first part of the promotion pipeline. Okay, so let's go back to the anatomy of the Docker image. So we spoke about owning your own framework build, and that was that, right? And now we have the other build, which is application. And if you remember, our application is adding one Java file to the framework build. And that's exactly what we do. Framework is your build, is your base now. You run your Java build or whatever other build to get your application artifact, and then you add this file to your base image, and you're done. This is all you do. And this is my application build file, right? So I use my own base, and then I add one file, it's one line. I go to, again, my repository, my artifactory. It supports also, so we spoke about how it supports Java, how it supports Docker, we spoke about how it supports RPM packages and Debian packages, but it also supports your application language, whatever you write. Java, .NET, Native, Python, Ruby, PHP, Node.js, Bower, whatever you work with, you get this file from here as well, and that's your controlled environment, so you're safe, and then you add it to the right place. And here you say, okay, now why we have a release repository here? Does it make sense? It depends. If you are able to test your application without Docker, and you want to do it, you want to build a whole pipeline for your application file before you contain it in a Docker image, you will have a separate pipeline. You will have your Java dev, Java staging, Java release, and then you will test your application in a complete different pipeline, and only those which are successfully promoted to the release repository in your Java build, you will take them to Docker. That's one way to do it. And another is no, it doesn't make sense. I have an application that only works within certain Docker image, and that's, by the way, the majority of the cases. So I actually don't need a separate pipeline for my Java artifact. I only build it. I build it once. I have one repository. I take it to my Docker, and then I go through the promotion pipeline on my Docker image. So that will be your answer, whether it should be like Java local or the whole pipeline with multiple repositories with security gates for Docker as well. And then here, now we spoke about not relying on the latest, and that's exactly what I do here. This release token is the way to say to Artifactory, bring me the latest release artifact. And then you say, wait a second, didn't you tell us not to do it? Well, this is different. This is an artifact that I build and I trust. Either I trust it because it's going to enter the whole pipeline that I'm going to pass it through, or I trust it because it's already been through its own pipeline and now it's safe. Either way, last build artifact is the artifact that I want here. I don't need to do this filtering when I'm here. And here again, you remember we spoke about never doing latest? But this is our latest. This is our base image.
Maybe, unless you're updating the OS or something, and you might want to still work on a previous version, right? That's what you...
Yeah, so no, you can write here any version you like, but you are okay with using latest here because this is your base that, if you remember, you picked, you tested, and now you own and trust. So that's okay. And if this latest is actually just a wraparound CentOS 7, that's because I picked CentOS 7 in certain point of time. I resolved it into my base image, and now it's okay to take the latest of my image. Does it make sense? All right. And here is another something new that you will learn from today, a term called a sandwich testing. I bet none of you heard about it. Right. So when you type it in Google, it does this, extract from the first result, and that actually means that it's definitely a thing and it's true and you can trust it, right? If it doesn't give you a list of results but instead do that, you say, okay, this is true. That I know. So here, it does that. So sandwich testing is a thing, obviously. And it's actually a very bizarre flavor of integration testing in which you do top-bottom and bottom-up in the same time. It doesn't make sense for a lot of cases, but it actually makes perfect sense in our case. We have two pipelines. You remember, we have the framework and the application. and we test them one with another. When we have a new application pipeline, we will test it with the latest known good base. And when we want to introduce, for example, new version of CentOS, or new version of Java, or new version of our application server, we will test it with the latest version of application that we know that works. We will bring it to our system test environment and test here that updating my Java version in the framework pipeline didn't break anything. Is it rock solid? Can we get into this? Well, theoretically, yes. For example, if we use some feature in our application that requires a new version of some framework in my framework. And then it's kind of, and those changes, both mine and the framework, are not backwards compatible. Then I will get to that. Chances, I would say very low, and I think we can hope that it won't happen, and if it will happen, we'll figure it out, because the chances are very low. But if you have a good triggering system, if for every change in your application build you test it with the latest known framework, and for every change in framework you always test it with the latest known application, I would say the chances are very, very slim, close to zero, and can be ignored. So this is all for me. And conclusions are, as usual with JFrog Talks, release fast or die. We are in the business of speed, and we try to help you to release faster and release more solid quality of your software. I hope this talk will help you do that at least a little bit. And with that, thank you very much. Links, right? That's me on Twitter. That's our hashtag, yep. I guess. That was an easy guess. JFrog.com/show notes. The video, probably from the airport lounge tonight. Slides, links, feedback, and raffle. Please visit that for all this information. Thank you very much. Any additional questions before we go to the next talk? Yes.
What are the limitations of memory for the Docker containers? I was looking at something that's 700 gigabytes, and I tried to save it down to 70 gigabytes, but
yeah.
Library. I was wondering, are there any limits for the containers to be? I understand it's
on limits on which level? If you ask about Docker registry, like Artifactory, we don't have any. You can take you can put their files of any size. If you ask about, well, I guess it depends on the tool, right? So I can say about our software, it's not limited by any way. Whether it works the same way in the Docker Trusted Registry or Docker Hub or Nexus, I'm not sure. But for Artifactory, for sure, you can upload files of any size until the socket connection times out. Okay, thank you.
All right, so next speaker's setting up. There's probably some more pizza back there if anyone wants it. Give us a little leg break.
Take a 5-minute break?
Yeah.
Or? All right.
Break.
Yeah.